Good morning, everyone. Is it weird when I'm coming from just like nothing? Good morning, everyone. How are you going? How is everyone feeling on this bright and early day? I hope everyone is well. I feel like, yeah, it's 10 a.m. It's early, but then someone said it's 5:30. That's even earlier. So well done you for joining us at 5:30 a.m. Not sure. Yeah, that's commitment to the code. A few people have just woken up. You see, that's the beauty of not having to roll into... I do miss the lecture theatre though. I loved seeing some people rolling in their pyjamas. It was just such a vibe. I do miss that, and barefoot. Oh, I can't wait for lectures to come back. Okay, so welcome to today, Wednesday. Well, it's half day. Yay, halfway through the week and week 2. We're going to do a lot of things today. So yeah, get ready for this. It's going to be a big day. So I'm sorry that some of the lab exercises haven't quite lined up with the lectures, and that's because the first 2 weeks are always really hard to align because we now start tutorials in week 1. So don't worry, we're going to cover enums today. You can do the zodiac animal exercise without enums, but I would love it if you tried it with enums as well so that you can get a taste for why enums are useful, and we'll talk more about that today, why they are useful, why people use them. But it's just giving you another thing, in your little briefcase of things that you can use. So in computing, we can solve many problems in many different ways. It's not like there is only one way to solve a problem. There's many different ways to solve each of the problems that we get. One way might be more optimal or more efficient than another one, but then, but that you're not up to efficiency, so you can still kind of do whatever you want to try and solve things. So on Monday we talked... Why is it cutting me off? Look at that. Let me just fix that. I'm using this, I forgot to bring my trackpad in, and I'm using this mouse that is just horrific. There we go, that's better, isn't it? Yeah, that's better. Yeah, you can still get full marks for the lab exercises if you don't use enums. It's not, yeah, you still can do that. In the specific questions that we want you to use a specific something, we will say, use specifically this, and then you have to use that, and we check for that, and that's really in the exam hurdles because we want you to use an array, we want you to use a linked list. Anyway, on Monday we did some basic if statements, and then we did some conditionals, so how to do and, ors, then we also did less than, greater than, assigning, not, and so on and so forth. We looked at more complex if statements, and then we did some scanf errors with catching those with if statements, because scanf is a weird little function that does a lot of weird things and can have some, quite a few quirks and vulnerabilities. And then we started to talk about while loops. I started rushing a bit towards the end because I was like, oh my gosh, we've spent so long on if statements. Let's get on to while. So don't worry, we're going to do more while loops today. And then what we're going to do after we do the glorious while loops is we're going to learn 2 more data structures, and we're going to look at structs, and we're going to look at enums. We're going to learn about 2 more data types today, data things that you can store your data in. It should really say custom data types. It's because I was thinking of structs and I wrote structures. Okay, where is the code? I think Tom's already way ahead of me. Oh no, he's posted the slides, so now he can post the code. And then let's do a refresher on your if statements and your loops, loop-de-loops. And at some stage today we will also I think play a Kahoot that I made last night. So hopefully that will, that will be a bit of engagement, a bit of fun in between all the code. So I don't know, tea or coffee, keep drinking tea until you ask for coffee. I think I'm going to go back to ice cream, of course. Sorry, I use it as one of my enum examples. I just can't. Someone keeps talking about ice cream, and that's all I really want. I really want ice cream. It's been like days. I really need to just go and get ice cream so that we can move on to different examples. Tea or coffee? Keep drinking tea until you ask for coffee. I'm not really sure. This is what happens late at night when I'm drinking tea. And favorite ice cream? Dolce de leche. Always, forever and ever. I spent quite a few months backpacking around South America, and I came back with a mad addiction to dolce de leche on absolutely everything. Breakfast toast, afternoon meal, evening meal, ice cream, everything. Passion fruit, geez, Tom, that's an odd favorite flavor of ice cream. Oh, chocolate, we've got a few. Oh, the Maxi Bonds. Oh, my partner loves the Maxi Bonds. And someone does. Pistachio is a delicious. Oh my God, look at all these amazing. My house, everyone just brings me dolce de leche ice cream on my birthday. The freezer is usually empty beforehand, so that's what everyone comes in with, liters and 1.5 liters of this just pure caramel. Anyway, okay, let's talk about loops. Back to loops, away from ice cream, even though I'm very easily distracted by ice cream or dogs. Anyway, okay, so C normally executes things in order. That means we go line by line, and that reminds me that we talked about what a procedure is, but we never moved any procedure out of our main function. So we're going to try and do that today as well, so that you can see how it's done. So C normally executes things in order. That means it goes line by line. It doesn't know, if it's on line 10, it doesn't know what's happening on line 20, right? Or even on line 11. It's not reading ahead. So that means that once we come in, we start at the main function and then we start reading down. So if statements allow us to turn pieces of code on and off, that means we're going to go into this line of code, or we're going to skip it and go up until now. And then while loops allow us to repeat code, because we wouldn't be able to, we'd have to just keep copying and pasting the same piece of code without a loop, one underneath the other, so that we can keep kind of reading it as well. So it's pretty important that we have these types of while loops happening for us. And just to remind you, a while loop has this wonderful, I don't know why it's wonderful, but I guess it's okay. It's just a pattern. So the pattern is you initialize a variable that you will control your loop with outside of the while loop. Then you go inside your while loop, that's inside the curly braces, everything that you're going to be repeating over and over again. And the expression part is where you test that loop control variable. You ask a question with it, or you find out if something is going on or it's not going on. And then at the end of your while loop, before you exit out of it, you would update the control variable so that you don't get stuck in an infinite loop. Okay, so the one issue with while loops is you can be stuck in an infinite loop. Should we do an infinite loop? Okay, let's do an infinite loop. And this is why I'm always running late. What does infinite loop mean? What do we reckon? What do we reckon? Yeah, melting computer time. Yeah, condition is never satisfied, so it keeps repeating. It doesn't know how to break out of this loop, okay? That's really all it means, is that you do not update your condition, or your condition always holds true. So it never knows how to break out of it, so it will keep repeating that piece of code. Third time lucky to write return. Okay, so let's come up with, I don't know. Yeah, no closure. I like that. Okay, whilst 1 is greater than 2. Printf. Well, this is not going to be, I was going to say dogs are more fun than cats, but that will be a very, very, very controversial opinion, I think. Oh, what should we print out? I'm going to keep it boring. Okay, someone said, shouldn't it be 1 is less than 2? It should be. The crocodile is not switched on yet. It's still too early in the morning. Yes, it should be whilst, yes, we do want, yes, the crocodile, I'm back. I swear, I am not a morning person. This is, you're getting to see the best of, okay, let's compile it. Actually, you know what, I'll give you access to it if you want. And then I'll run it. Okay, great. My favorite mistake, forgot a semicolon. Did anyone pick that up? Yes, someone has picked it up. Oh, I love. Okay, let's do it. Here we go. And infinity. It's just going to keep going forever and ever and ever. Well, it will stop at some stage when it's just going to terminate on its own, right? At some stage. But how do we end this? Does anyone know how we end this? Okay, yes, the few people do know. Control C. So if you press Control C, it will end it, okay? So what it will do, you see over here, this little star, that's what I've pressed Control C. That's saying I've pressed Control C, execution was interrupted, execution stopped in main, infinite loop on line 11. So, yep, I've stopped on line 11 because I didn't ever break out of this loop. I couldn't break out of it because it was always true. Because the condition's always true, it's going to keep repeating itself. So anytime you enter an infinite loop, and it will happen when you're coding, okay? Or anytime your program will not stop running, Control C. Yes, Tom is correct. Yeah, because I pressed the command key first because I have a Mac keyboard and inside VLab. Yeah, so Control C is the way to stop that infinite loop from occurring. So, you know, sometimes you do get stuck in infinite loops. That's okay. That's part of learning, you know, how to have a good time whilst coding. Usually when you get stuck in an infinite loop, it means that you haven't updated your condition. So, you know, you might have, even here, I might have int count is equal to 0 where I initialize my loop control. So initialize loop control. And then here I might say whilst count is less than 2, then do this condition. Okay, so I've tested for the condition and then I've got the print, and this is going to result in exactly the same thing occurring because I never update my loop control variable. Okay, so this is usually the common problem when this occurs. Okay, so whenever you see an infinite loop, just check that you have updated it. So I've never done count is equal to count plus 1, which means that it will increase, and that means that it will actually stop at some stage when that condition no longer holds true. So now if I compile it and run it, it's only going to print it out twice because it's going to do it for 0, 1, and then when it gets to 2, it's going to say, well, 2 is not less than 2, so I'm going to exit out of this while condition, and then I'm going to come out of it. And so a few people, yes, you can, instead of this, absolutely, you can shorthand it. You can say count plus plus, which means count is equal to count plus 1, or you can do plus equal 1. So all correct ways to do it. Okay. Good job. Everyone's happy with an infinite loop, I think. Maybe not. Okay, so there's 3 ways to control a loop, and you know, there are ways that are more efficient in the context of the problem to what you need to do, but sometimes you have a bit of a preference, And sometimes you like try and push all of your kind of logic into that preference of how you organize your while loops. And okay, someone said, well, what does plus equals do? You can say it just means, so if you have count plus equals 1, it means that you're adding 1 each time, and you can do 2 here and it will add 2 each time, or you can do a multiply here and it means it'll multiply by 2 each time. So it's just a shorthand way, and we're going to look at it next week, all the different shorthands that you can do. Yeah. So if you do plus equals 5, it will add 5 every time. That's right. So it's a shorthand way of writing it because, when we code, I don't know, we're a bit lazy when we code. We like the shorthands. Okay, so there's 3 different really ways to control what is going on. And let's have a look at what those ways are. Okay. Oh, I should have written that. That was you see, I can't function this early in the morning to come up with creative things. I came up with this, but it was daytime. Well, probably midnight, but anyway. Okay, so using a control like a loop counter to control the loop. So this is what I've just did really up there when I said I had a count variable and I used it to count up. And then each time I updated the loop control variable. So that's a count loop. That's really I think it's the most fun loop to do because it just keeps counting. So what happens is this. If you want me to run through things ever, just let me know. But basically, it says here count is equal to 0. So it will do... I forgot to open the thing that controls it. What's the blackboard thing? I'll find out what it is in the break. And then we'll go through it in a little bit more detail. Okay, so that was one way, count. We kind of did an example. We'll go back to it. Don't worry, we're still going. Then there is another way, okay, to control a while loop, and that's to do a Sentinel while loop. Now, what does Sentinel mean? Has anyone heard of the word Sentinel when it's used in this sort of coding context? Has anyone ever heard of the word Sentinel? Basically, what a Sentinel is that it's like a flag, okay? We either switch it on, we switch it off, we basically, we use it as a flag that something has happened, then we'll switch it on, or if something hasn't happened, then we'll keep it off, or the other way around. So basically, it's a flag value. It tells the loop when the loop can stop. Okay? So, for example, keep scanning in numbers until an odd number is encountered. Okay? I mean, I guess it's kind of it is like a Boolean in some ways, but a flag can be it's like a state. That's a really good one. So it's like a state. Is it switched on or is it switched off? So it's like I'm checking for the state and then I'm doing things. So let's do this example. Why not? Keep scanning in numbers until an odd number is encountered. Oh, here it's a negative number. Well, let's do negative number. Why do I come up with these examples? I don't know. Okay, let's do hash include stdio.h, and then we'll do our int main void curly brackets. Okay, so we've set ourselves up to code. Now let's look at the problem. The problem is I want to read in some scores until a negative number has been entered, and I want to only sum together oh my god, no, I'm going to make that a lot simpler, okay, because I want to be able to have other things to do. So I want to read in some scores until a negative number has been entered and sum them up. That's it. I'm not going to conditional sum them up. Ooh, the prime number. I love the prime number. I once wrote an exam where 3 of the questions were about prime numbers. That's never going to happen again because that's a ridiculous overuse of prime numbers. Prime numbers, they're so cool, aren't they? I don't know. Oh my God, nerd. Just sorry. Prime numbers. Okay, I want to read in some scores until a negative number has been entered and sum them up. So let's have a think about what is needed here. Okay, so I'm going to comment this out and we're going to talk about how we're going to do it. Okay, so first of all, I guess we need to ask the user for a number. Then scan in the number. Yeah. Then what do we need to do? We might need to check if the number is positive or negative. And then what should we do? If the number is negative, stop scanning. And if the number is positive, keep scanning. No, not keep, add to the sum and ask for the next number. Aha. Yeah, okay, yeah. So this just means it's a long comment. It means I don't have to enter these 2 dashes on every single line. Anything in between slash star and star slash is considered a comment. So it does the same thing. Yeah, it does the same thing as just doing multiple slashes. Yep, so we'd have an if and an else, absolutely. We're scanning in some numbers, so this will be a scanf. We're asking something from the user, so we might print out something here. This is definitely an if statement. And this is definitely an if statement. Now, if I have a condition that I have to meet, so if I'm constantly checking whether or not I'm going to keep doing something, this seems like a really good place to use a Sentinel value, okay? So I can use a flag to let me know if number is positive or negative, to keep loop going. So let's have a look at how we can do this. Okay, so I'm gonna call it a Sentinel just so that you kind of get, I don't know, so that you would know what it would, the variable name aligns to what it's doing. And I'm going to set it to 0, okay? And it doesn't matter if you set it to 0 or 1, as long as the other state is the opposite of that, if that makes sense. So let's do, okay, Sentinel value, flag, that tells us it really tells us if we keep going or stop. Okay, so initialize to 0, which we will assume to be the case to keep going. Okay, and I guess because we're adding things, we're going to need to keep track of the sum. So I'm going to initialize the sum as well. That's what we're going to keep adding to. And so now let's create our while loop. Okay, so we've got our loop control variable. This Sentinel here is the flag that we're using to control our loop. So I'm going to say whilst Sentinel, what should we do here? What do you reckon? What should my condition be? What do we think? So when it's 0, I'll keep going. As soon as it changes over, I'll stop. And remember, it's like a state. It's got really 2 things happening for it. Yeah. So whilst it's equal to 0, I'll keep going. Okay. So my while loop is going to say while Sentinel is equal to 0, I'm going to do something. Somewhere inside that while loop, I'm going to have to change the Sentinel value if something doesn't, you know, if I need to stop. Where should I ask? Actually, no, let's do it. And then you'll see the mistake that might happen. We'll see if you can spot this mistake. So let's print out. Okay, so can I please have a number to add? We also need something to store the number in. So I'm going to say int number, that's what we're going to scan into. So let's scanf, and it's going to be a %d because we're scanning, and don't forget the ampersand and number. Okay, so now I have a number, and what should we do now? We should check that number, shouldn't we? Now is the time to check if the number is positive or not. So we've done ask for the number, we've done scan in the number. Now we need to check if the number is positive or negative. So let's check if the number is positive or negative. So how can we check if the number is positive or negative? What do we reckon? How do we check if a number, so if number is greater than 0, that means it's positive. So if it's greater than 0, then we're going to update our sum. So we're going to say sum is equal to sum plus number. And that's it, yeah? Else, what are we going to do on the else statement? So otherwise the number is, and someone is correct, it should be greater than or equal to 0 because 0 is still a positive number. Yeah, we'll just say it's a positive number so we don't want to stop for 0. Yeah, so the else is now, if the number is positive, then we need to add it to the sum, else the number is negative. And if it's negative, I really want to stop scanning. So someone is saying we need to change the value of our Sentinel. That means I'm going to set Sentinel to 1, okay? Because I'm going to say no breaks, breaks only for debugging. I don't want to, don't break out of the if statements if you can, which most of the time you can. So I want to move my Sentinel, I want to set it to 1. So now what will happen is when it's sitting in here, Sentinel is 0, it's going to ask for a number, it's going to get the number. If number is greater than or equal, it's going to add to the sum, else it's going to set the Sentinel to 1. So what else do we need to do? I guess we should print out the sum in some place. So maybe we'll do it outside the if loop. Now there is actually a few mistakes here. So let's see what they are. Okay, and these are all common mistakes. So I'm gonna save it and compile it so that you get a feel for them. Okay, let's clear this out. Okay, someone's saying I didn't declare sum. I did declare sum and initialized it. It's going to compile. Oh gosh. Okay, it compiles, it's fine. Yeah? But there is mistakes in it. There is a lot of errors. Okay, can I please have a number to add? 6, beautiful. 7. Who's keeping track of the sum here? Who's keeping track of the sum? 6 plus 7, 13. Plus 7 more, 20. 23. I'm going to finish here. The sum is 23. Yes, everything is working. How fantastic. But is it really? Let me run it again. What happens? Actually, how do you think I can break it? What do we reckon? How can I break it? And this is a good way when you write your code, you know, and everything is working and you're celebrating. Think about how you can break it first before you celebrate. Okay, people are saying a letter. Let me try. I'm going to do a letter. Yep, that's going to break me up. Absolutely. Yes, someone's got it. What happens if I start with a negative number? Well done. If I run it and start with a negative number, what's going to happen? It's just going to give me the sum is 0 because I initialize my sum to be 0. It's just going to skip the whole thing through. So that's not that bad, isn't it? Okay, so the character breaks things for us. So how should we take care of that? What do we reckon? How do we take care of the fact that it breaks when we get a character? So we've got a scanf %d. Yeah, check scanf. Let's do it. We don't want a %c. We want it to take in. Who remembers how we do how we do checking for our scanf. So I'm going to have a scanf return here, value. Remember, scanf keeps the amount of things that it's scanned in correctly. And then what I'm going to do is I'm going to check that it's equal to 1. So I'm going to check inside that if statement that in fact it's scanned in a number before I proceed. So if that scanf return is equal to 1, that means I've scanned in a number and I'm happy to keep going, that means. So I'm going to take this, I'm going to cut it, I'm going to stick it in here. And then I'm going to fix the tabs because my eyes are bleeding. Okay. Good. We're going to learn better ways to do it. I've nested quite a few ifs here. It's still not bad, but we will learn better ways to do it as we go. But we just don't have enough things in our arsenal without nesting for now. Okay, so let's save it. Let's run it again and try that mistake again. So let's compile it, compile and run it. And now I'll enter an A and oof, that hurts, doesn't it? That really hurts. I am now in an infinite loop. And why is it that I'm in an infinite loop? Who can tell me why I'm Who can tell me why I just went into an infinite loop? Yeah, so I said here, if scanf return is equal to 1, do all of this, but it is still inside the while loop, okay? I haven't said exit out of this while loop if it's not, right? So what happens when this scanf is else? Okay, so we need to consider else. We really want to be breaking out of this loop. And the way to break out of this loop, we can either finish the program, we can say return 0, or we can set the Sentinel to 1 as well, because it's not a number. Or we can say here, you know, you did not enter a number, please enter a number. So it depends, right? It depends how you want to, what the specification is for this problem and how you want to complete it. So I can say here, and I can exit out of here. Now look at this, actually, I'm going to do a different return here. I'm going to return 1, okay? So usually when you, and just so that you can, there's different ways to do this, but so that you can see returning something other than 0. So when I return 1, what it means is I'm telling the program that something finished with an error. It didn't finish successfully, okay? So that's really all that it means. I can return whatever on earth I want. I can return 42 in there, 13, whatever, right? A number other than 0 usually means something's happened. 0 is successful finish, 1 not so successful. So let's run it again and let's try it again and let's enter a letter, and it's just going to say you did not enter a number, and then when it does return, it exits out of the program. So it's going to exit out of the whole thing, right? Okay, how's everyone feeling about Sentinel value? And it's just one way to control your loop. How are we feeling? Can you poll? Okay, whilst Tom is polling, thank you, Tom. We're going to do a conditional loop, and I think we kind of did a conditional loop. I think I did it last time. What does the scanf return do? Okay, that's a very good question. Basically, when scanf is a function inside a library. Okay, so this scanf is a function. And scanf has a return value, okay? So what the return value is it's the number of things that it's scanned in successfully. And so I've just declared a variable. I called it scanf return. It's just what I named it, okay? It's not, you can name it whatever you want. But to me, that's a variable name that made sense because it's the one that's keeping track of what scanf is returning. So I've placed that result inside scanf return. So if someone puts in a number, that means scanf is going to return 1 because it's scanned in one thing correctly. But if someone puts in a letter, it's going to return something else, 0 or something else. And this is what this else statement is. It's catching it when someone puts in something other than a number. If you enter 2A5, it's going to read the 2 and ignore everything else. So it's still going to be successful in scanning one thing. Does it make sense what the scanf return does? The return value can be more than 0 or 1. If I'm saying, okay, I can do this as well. Can I please have 2 numbers to add? And then here I might have number 1 and int number 2. And same way as when you do your printfs and you can have multiple things here, I can also do multiple things here. I can tell it to expect a %d and a %d and tell it that it's going into n number 1 and number 2. So now, if it's successful, this scanf return is going to return 2 for scanning in 2 things successfully. It could be 3, it could be 4, it depending how many things I'm asking it to do. Okay, I hope that makes more sense. Okay, that scanf return is really how we check for errors, right? It's how we make sure that we safeguard our code from breaking all the time. Okay, so that's our while loops. How amazing. What happens if you put a while inside a while? Oh gosh. What happens if we put a while inside a while? We get something very exciting. Sorry, I'm just trying to give you access to this file. Give me a second. Okay. When you put a while inside a while, you basically get a loop inside a loop. That means each time a loop runs, it runs the other loop. And the inside loop runs many, many times. So think of it as your clock, and you know our hand or even our minute hand, it moves once for every 60 movements of the second hand. That's a loop inside a loop. So the minutes is the first while loop and nested inside it is the second. So the second hand is going to run 60 times before the outside loop just does 1. So basically what that means is you can do things like this. You can print out whole grids, right? Or you can print out, you know, in a row and a column format. You can do a lot of things then using this while inside a while. Okay, so let's try a problem that kind of uses that, just so that you can see how that's used. And then Tom's polling. I'm just going to quickly have a look at the results of the poll as well. And don't worry, I'm going to keep doing things. I'm going to keep doing things over and over and repeating things as well. So just let me know as well at the end of a lecture feedback if you want to go over anything again, because in the following lecture, I'll pick up and do another example based on what you didn't quite understand. Okay, so our problem is print out a grid of numbers that looks like this. Fantastic. So if we look at it, we've got 1, 2, 3, 4, 5, 5 numbers, and then there is 5 rows, columns. Oh, this is my other painful, the less than, the greater than, rows and columns. Columns are up, rows are that way. Yeah, because column, the building column. Okay, but you'll get a lot of fun out of this because I will always put them on the wrong ways. Okay. So let's do grid of numbers that looks like this. Okay, how on earth do you do this, right? How do you even approach a problem like this? It seems a bit overwhelming maybe. So what you need to do is break it down until you get to a place where you're like, okay, I'm happy I can do that. Can you print out a 1 for me? Yes, you can. I think you can. I hope you can. And can you print out 1 to 5 for me? I think you can as well. So let's try just printing out one line and then we're going to see if we can print out the whole square of it. Okay. Okay, so someone's saying when n is less than or equal to 5. Sounds good. So I'm going to hash include stdio.h and then int main void. Oof. Okay, I know I can print out that 1, 2, 3, 4, 5. Okay. For those of you that are tempted to do print out 1, 2, 3, 4, 5, I would urge you not to do that. Okay, because, you know, why wouldn't we do that? We wouldn't do it because this is not very flexible programming. It's just hard coded in, which means that, you know, if you want to change anything, you're not going to be able to. It's just going to be printing out the same thing all the time. So what we want to do, you know, while Sentinel is it not saved? It might not be saved. It's in the code. There we go. It's saved now. It should update in the lecture code. Okay, so this is not what we want to do. So how do we print out 5 numbers, you know, using not hard-coded in? Okay, I'm going to use a while loop, and I'm going to control that while loop with a loop control variable. So I'm going to initialize a loop control, and it's going to be an int, and I'm going to call it count. I'm going to set it to 0. Great. Now I'm going to check for the condition. So whilst that count is less than 5, I'm going to print out the number, the count, %d, and I'm going to put a space there as well. So I'm going to print out the count, and then I'm going to update. So update the loop control as the last statement in the while loop. So I'm going to count ++ to add 1 to it. Okay, what's this going to do for us? Let's have a look what this does. And when you're doing your coding, you know, try little things at a time, okay? Because once you do a big chunk of code, you're highly likely to break something, and then it's much harder to go back and find where the mistake is. So let's do, I didn't mean to write greed, but now it is, so whatever. Okay, so it's printing 0, 1, 2, 3, 4. Great, we have a bit of an issue, don't we? What do we want to change? And this is what I mean, you do something, you try it, and you see what's going on. So what do we want to change? How do we think? We want it to print out 1, 2, 3, 4, 5. So what should we start our count at? Yeah, we want to start the count at 1 in this case. Excellent. And we want to keep going until it's less than or equal to 5. Perfect. Excellent. Okay, so let's see what that does now. Okay, great. Now it's printing out 1, 2, 3, 4, 5. Fantastic. Or, as someone said, you can have counters less than 6. You can do that as well. Yeah, that's me not being able to spell. Okay. Wow. Okay, we did it. We got 1 line of code. How do we now get 5 more lines of code underneath it? How do we now press enter and have another while loop inside? Yep, so we'll use another loop. Someone's wanting me to use a for loop. Not yet. I will use a for loop next week. Yeah, add another while loop. Okay, so someone's saying add another while loop before the count ++. Okay, let's do it. So I'm going to print out that %d. And what am I going to do then? Do you think another while loop in here? And what's going to be the while loop in here? Do you think the while loop will go in here? So we'll have, let's say it's going to be 1. It's going to go in here. It's going to say is 1 less than or equal to 5? Yes, it's going to go inside here. It's going to print out the 1, and then it's going to go into the next while loop. So do we think that's going to work? I really wish I had the pen working so I can draw it. Okay, it's coming. It's coming. I'll be able to draw it. Yeah, that's not really going to work, is it? Okay, let's try it on the outside. Okay, so we need to have, let's try it outside here. So whilst, we might need another variable, don't we, to keep track of our rows and columns. And we do need a new line somewhere. I absolutely agree with that. So what do we reckon we're going to do? How are we going to wrap it? Let's try another while loop. So I'm going to make it a row and a column now, because one is going to keep track of rows and one's going to keep track of columns. Is that okay for everyone? And what should I initialize it to? Well, I can have just 2 conditions called something else. The thing, like, I find it easier to keep track of things when I've got rows and columns. Then I really just go crazy for rows and columns, basically. And often you'll see people keeping track of with I and J. It's like the only time that it's okay to do. Should we try that? Why not? Let's try that. Well, I'll call them I and J. So you'll need 2 lots to keep track of the 2 loops. Okay, I'm going to keep them at what? 1 or 0? I guess this one doesn't matter. Okay, let's do our outside loop. So I'm going to say whilst I is less than 5. So it's going to be the one that's going to count that way. And then inside this one, and then you can tell me if something is going to go wrong here. I'm going to place this loop inside the other one. And then we're going to run through it. We're going to hand execute it so you can see what actually happens. Then I'm going to delete a W by accident. Okay, no, I haven't, yeah, so I'm changing them all through now. Okay, and okay, I've done this loop, I've done that loop, but I haven't updated my loop control variable for the outside loop, so I'm going to do that here. But there's still something else I need to do, isn't there? Let's see what it comes up with. Shall we see what it comes up with? Why not? It's not going to be pretty. Just brace yourselves. Not pretty at all. Why is it doing this? What do we think? And this is another really common mistake in a nested while loop. Let's run through it to see what it's doing. Okay, I've set I to 1. Then that really should be is equal to here. I is 1. Excellent. J is 0. So here I've got I is equal to 1. Is 1 less than or equal to 5? Yes, it is. I'm going to go in here. Is 0 less than or equal to 5? Yes, it is. I'm going to print the 0. And then I'm going to update it to 1. I'm going to keep going back to here. I'm going to keep going back to here. I'm going to keep going back to here. I'm going to keep going back. So I've done it. So now my J is equal to 6 at this point in time. When I leave this while loop over here, my J is equal to 6 at this point in time because I've just updated it. And this is the first time it's going to fail this condition. Then I go here, and this I is now 2. Is 2 true? 2 is true. I'm going to go inside. But here, this is now a 6. So this is a really common mistake. What happened is we haven't set the J back to 0 to be able to kind of go on and do this again and again. So we really want to be resetting the j. Okay, so let me reset. I'll put j as 1 as well, just so it doesn't get confusing. And here what I will do is I'll reset, I'll declare the, you know what, I'm going to get rid of this line and I'm going to have my j inside here. And then let's see what happens now. Shall we see what happens now? It's still not going to work, but let's have a look what happens. Haha, very good. It's now printing out 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Amazing, but it's doing them all in one line, which is not what I want. So I want a new line somewhere. Where will I put my new line? What line, in which line will I put it in at, do you reckon? Will I put it somewhere? Will I put it in 31? Will I put it in line inside the second while loop? Someone's saying line 27. Okay, let's have a look. Okay, I've done a new line. Let me show you what that does. Haha, it's just printing them all out, because if I put it in here, it's going to do it after every J. That's after every column entry. So this is not where I want it. But it's an easy mistake to spot, right? So don't be scared to make this mistake and be like, oh yeah, actually that's not a good place for it. I really want it when it finishes each column. So when it finishes doing one column, I want it to then do a printf new line. So line 30, it was line 32. So whoever, yeah. So let's do a new line and then we'll keep it going. Let's save that. And here, let's compile it and run it again. Beautiful, look at us go. We've got a beautiful grid going on. Amazing, it's everything that we've ever wanted. How stunning. Now, how stunning is that? That really is just, okay, we've solved a grid. The next one was a pyramid. I wonder if we have time to do the pyramid now. Should we do the pyramid? Can you poll loop inside a loop? Thank you, Tom. Okay, so good. Let's have a look at a pyramid. Okay, let's make it a little bit harder. I don't know why. But let's see if we can do it. We'll do the pyramid and then we'll take a little break. I would love to explain it one more time. You know what? Let's maybe hold on the pyramid. We'll leave the pyramid to the end. Let's go back to the grid, and you know what I'm going to do? I'm going to get this board working. I can't remember what the thing is called for the board. That's my problem. I'm just going to try board. Because then if I can get a pen and yes, open board. Here we go. Okay. I'm going to draw it for you. It's going to become a lot more clearer. All right. Okay, and I'm going to go to a pen. Ooh, red pen. All right, here we go. Let's do it. Okay, so over here in my code, I hate it when it does that. I'm just trying to up it a little bit. Let me just open this for you a little bit so that you can, I'm just going to open this up so that you can see all the code whilst we go through it. Okay, so we've got our first thing here. It's int is equal to, I is equal to 1. So when you're on this line, what you're doing, you're substituting I is 1 less than or equal to 5. Yes, it is. This is true. So that means I'm going to go inside this while loop. So at this point, I is equal to 1. Let's keep it track over here, and we'll do j over here. Okay, so I is equal to 1. I'm going to go in here. Now in here, I'm saying j is equal to 1. Great. I'm going to move j in here in 1. And now I'm checking, is 1 less than or greater than 5. It's true, which means I'm going to go inside this loop here. And what I'm going to do is I'm going to print out the j. The value of j is 1. So that means my printing over here will print out a 1 and a space. So that's when I've done that. I will then update j to be j++, which means that j is now 2. Okay, I finish this while loop and I go back to this while loop to check again, okay? Is 2 less than or equal to 5? It's still true, so I'm going to go in here and I'm going to print out the 2. I'm going to print out the 2 in a space and then I'm going to update the j again. So now j is going to be 3. I go back, I finish my while loop and the curly, I go back to here and I check again. Is 3 less than or equal to 5? It's still true. So I'm going to print out a 3 and I'm going to move down here and update my j. J is now 4. Excellent. I'm going to go back to my while loop and I'm going to check again. Is 4 less than or equal to 5? Still true. So I'm going to still go into this while loop and I'm going to print out the 4. Excellent. Then I'm going to go down to line 30 and update my j variable. It's now 5. I'm going to go back to this while loop because that's what a while loop is. And I'm going to check again. Is 5 less than or equal to 5? It's true. So I'm going to go inside this while loop and print out the 5. And then I'm going to go down here to line 30 and update it. So now it's 6. So I'll go back to my while loop and I'll check the condition again. Is 6 less than or equal to 5? This is no longer true. It's now false, which means I exit out of this inner while loop and I move to this line over here. Okay, this says print the new line. So I'm going to print the new line. It means I'm going to go to a new line and I'm going to update my I. My I is now 2 because it used to be 1. And I'll go back to my outer loop and I'll check the condition. Is 2 less than or equal to 5? That is true. So I'm going to go back inside here. Now once I go back inside, the j is reset again. So the j becomes 1. And then I start this inner loop again and I'll keep going and going and going. Yeah. How is that? Does that make it more clear? How are we feeling? Yeah, okay, great, fantastic. And this is, this is one of the ways when we used to look for errors in code, even out in, industry, like yes, you use breakpoints and you have debugging software, but often I would sit down and I would actually write it down with pen and paper and actually go through it step by step and step through it because it makes it a lot clearer when you've made a mistake where that mistake is made. So it's quite a valuable tool in your briefcase. All right, so what we're going to do now is we're going to have a little break, 5 minutes. When we come back, we'll do a Kahoot and then we're going to do a few other things. That's it. LP, great question. Is there any reason we need to initialize J in the while loop? There is, because if it's initialized outside of the while loop, what happens is that it ends up being 6 the first time, and when I go back to check for it again, it's still 6. So I'll never get to go inside my inner loop again. Like I'll only get one row out. And it's a really common mistake in a nested loop that you forget to reinitialize that inside control. Because remember, for every minute that is moving, it's going 60 seconds around and then it needs to go back to 0. So we need to zero out that inner one again to start counting again. All right, quick break and then we will do a Kahoot. Oof. There we go, quick break. All right. Oh, I'm missing. Here we go. I'm back. I love it. It's like I'm a ghost and I'm back. Welcome back. I hope you had a good 5-minute break. I hope no one came from maths today as well, because that's extra painful. Just that much lectures. So let's talk about a few different data types as well, so that we can get a good feel for what's available to you, and we will write a bit more code as well. So don't worry about it. Lots of code coming up, and I'll see and then I'll write a procedure as well outside of the main, so you can see how that's done towards the end, just so that you can see a quick demonstration of it. Oh my God, yeah, the Kahoot. Yeah, let's do that now. Let's start with that. Thank you for that reminder. I'm off with the fairies half the time. Okay. How do I? Okay, here we go. Let's Kahoot. That's a good way to start. Wake up a little bit. Who will be the king or queen? Who will be the royalty today? Oh, look, I'm playing as well. Amazing. I'd win. I have an unfair advantage. Loopception. Loopity loop. Oh, Tom Killing. A few Tom Killings. Oh, getting into the puns. Fantastic. Green Sasha. I like that one. Steamed hams. The screen's a bit cut off. That's unfortunate. Let me fix it. Oh, it's completely cut off. Why is it? That's much better, isn't it? Oh, cats greater than dogs. I see where we're going with this. All right, shall we start? All right, ready, steady. Hope you've been eating spaghetti. No one knows what I'm talking about. Here we go. 3, 2, 1. For the end. Oh. Ooh, very nice, very nice. Very nice, okay. Here we go. Oh, not bad. Next one. This is very like... Ooh, very good. I see. Oh, a bit of movement in the scoreboard. Next one. That's the longest piece of code ever. Did I get overzealous with the chunk of code? Yeah, maybe a little bit. Tom's saying a little bit. Yeah, that that was me getting overexcited. This was really clearly who can guess the best. Okay, got too excited. Sorry. I'll know. I hope I wrote a smaller snippet. Yes. No more long snippets. So happy with that snippet of code. Oh, an equal tie. Wow. People didn't see the not, I think. Okay, a bit of movement. I think there's one more question left. No, two more questions. Oh God, it's another snippet of code. Oh God, it's another huge snippet of code. Can you see it or not really? Okay, last question. Here we go. For the win. Oh God, another snippet. No, I was nice this time. Oh, very nice. Very nice. All right. Let's see the results. Who's on the podium? Oh, Duke of York. We've got royalty in the midst. Oh, very nice. I was like, why did the screen go dark? Woohoo! Look at that. Amazing. And some runners up. Nice one. Okay. Let me move this out. All right, we'll do another one next week, and I will know not to do long snippets of code. Yeah, okay. Maximum 10 lines, got it. Oh yeah, Tom will see, yeah, good. Yeah, that will be good. Okay, let's talk about two more data structures. Not structures, I'm sorry, data types. We're not up to structures yet. Structures are coming. I know Queen Sasha did not win, disappointing. Next time. Okay, so we have these things called structs. Okay, and what structs are they're literally a box. They're short structures. It's a custom variable type. Okay, so what it means is right now you've got an int, you've got a char, you've got a double, fantastic, you've got all of these, but inside a struct you can keep different types together that are related to each other. So what that means is I might have an int, a char, and a double in one struct. And so basically I've created a box of things that are related to each other that have a bunch of different types in it. And the point of them is that a struct is made up of related variables. So it's just another variable that's made up of more variables. So it allows you to keep track of more than one thing at a time that is related to each other. So what happens when It's a data type. I'm sorry, I keep saying data structure because I keep thinking structure, and I keep saying structure. It is a data type. It's not, a structure is a bigger thing that can hold things, in it. And we will learn about our data structures in week 3, 4, one of those weeks. So this is a data type. Okay, but it's called a structure, a struct. So that's why I keep saying structures. Okay, so a struct, basically what happens if you wanted to group some variables together to make a single structure? And one example of this is really, like let's say my dog, one of them, it's got a name, the dog's got an age, might have a weight attached to it, and the age might be an int, the weight might be a double, the name is a string or a character, and I want all of those things to really be held together because they belong to one dog, okay? I don't want them to have as 3 separate variables. So this is what a structure is doing for us. It allows us to group different variables together that belong to kind of like one category, but they're different data types in there. Can you think of some examples in real life where things go together to make a single component? Can you think of that? Can you think of anything that you might like to share in the chat? What do we reckon? What's another type of data? Student gender and ID, yep. Books in the library, yeah, they might have a title, they might have the code. A human might have an age, a weight, I don't know, color, hair, height. Crust and filling make a pie. Oh, I like that one. Yeah, you might have, yes, fantastic. Material properties, yeah. Bank account, absolutely, that's a good one. Name, balance amount, a whole bunch of other things. Car color, number plate, yeah. Amazing. Juice, flavor, size, absolutely. Pulp, no pulp. Pizza, yes. Pizza is definitely an item that holds a lot of things on it, but it's just one structure, but you might have what vegetables, what cheese. Oh, yes, fantastic. What size? Good. What price? Excellent. Okay, good. Very good. Yes. So when we're creating a struct in C, there's 3 steps to it. I've got 4 fingers up. Three steps to it. First of all, you define the struct. So you have to let C know what is going to be, what is this struct about, what is inside it, okay? Someone's jumping ahead and saying, how is it different from an array? I'll tell you this now, even though it's an array only holds the same things inside it. So it is the same type of data in an array. If you have an array of ints, every single thing has to be an int. But a struct holds different things in it. So you can have an int, a char, and so on and so, whatever you want. And you can have an array of structs as well, which means that it gives you a lot more things to happen. So define the struct outside the main so that it's accessible to everything else in your code. And basically that's when you're saying, what is inside the struct? What is this struct called? How do I refer to it, afterwards? Then inside your main, you will declare the struct and provide a variable just like you normally do. And then you initialize the struct inside your main as well. So let's have a look at how we do that. I think maybe it's easier if I type it in the code, I think. What do we think? Yeah. Otherwise it's not as okay, let me open up. Okay, excellent. Let's have a look. Struct. Let's have a look at all the different things that we can have for a struct. Well, just one really. What should we do a struct of? What should we do as our struct definition? What should we do? Thoughts, ideas? Tom's writing something on the board. Student. So boring. I'm sorry. Everyone does student all the time. 151 teachers. I have done ice cream flavors before. Give me something creative. I know the pressure is on a Wednesday morning. Dog breeds, could do pizza. I do like the pizza one actually. I'm going to do pizza. Bikes, I don't really know enough about bikes. I know how to ride one, that's about it. Car is an excellent one actually. Oh, tree types is also a good one, but I don't really know enough about trees. All I know is that if I get a plant, I usually kill it. Okay, let's do a pizza. Why not? So, first thing we do is we define the struct outside our main. Okay, and to do that, what I do is I say struct pizza. So I'm saying what it is, okay? And then I do curly brackets. This is the only time in your 1511 experience where you will be placing a semicolon behind a curly bracket, okay? And the reason for that is that you can have something in there between the curly bracket and the semicolon, so that statement might not be finished. So you're letting C know that the statement is done, this definition is done, okay? It's really the only time in 1511 that you will do that. As a rule, right? It's just as a linguistic rule. No, you know, don't stress about it. It's not a problem. Well, I hope you weren't stressing about it. I've probably just overthought this, that it's stressful. Okay, great. So now we're ready to kind of define what goes in there. So let's do, because we'll do a char name, okay? And this will hold the name of the pizza, okay? Then I might do an int size for the size of the pizza. I might have a double price for the price of the pizza. Whatever it is that I want to, you know, put in there, I can do that. Maybe even we can have, you know, what crust it is. We might have a chart. I'm going to stop because otherwise it's too many things to then initialize. Okay, so define the struct outside our main. Okay, so we've got this struct. It's got 3 things in it, and it's an, you know, pizza. It holds 3 things: name, size, price. Now we go inside the main, and this is when I have to declare that I'm going to use this struct, okay? To declare that I'm going to use this struct, I'm going to say that I want something of type struct. So just like you normally do int variable name, it's exactly the same thing. My struct is struct pizza, because you can have more than one struct outside defined. So I'm going to say I want a struct pizza, so something of type struct pizza, and I'm going to call it my pizza. That's it. So you declare it in exactly the same way that you declare a normal variable, by saying that you want something of type struct pizza, and that's exactly what you're getting, and then the name of the variable. So in this I want it to be called my pizza. Okay, fantastic. So now I want to be able to put something inside that struct. Okay, so I want to actually assign things to these components inside the structure. And the way to do that is I use something, I use this little dot, okay, which allows me to access each component of that structure. Okay, and each component of this structure is called a member of this struct. Okay, so this is a really good question, okay? Why do you need my pizza? That's because over here, I could have another struct. What should the struct be? Struct, I don't know why I typed human. Anyway, human it is, okay? And this struct might have inside it int age, char name, something else, okay? So what I'm doing over here when I declare it is I'm saying which struct it is that I want to use, okay? And that's why I'm saying struct pizza. That's the struct that I want to use. and then I'm giving it a variable name of my pizza. So this struct is referred to as pizza, and then my variable name, how I will refer to it throughout my code, is to actually call it my pizza. That's how I'm going to access it. So pizza is the name of the variable. It's not enough, because if I do this, okay, if I do struct my pizza, which struct am I using? Am I using this pizza one, or am I using this human one? It's not, you can't, the code will not know what you're talking about, because it cannot read minds, contrary to popular belief. Okay, so that's why I'm going to say that I want something that is of type struct, and I want the pizza one. And I'm going to call it in my code, my pizza. I think I know what you're saying. Why is pizza not enough? Why do I need to have a my pizza? Great question. That's because over here, I might say, actually, you know what? I want a my pizza too. So I want to have something, I want to have 2 or 3 of these structures that have the same building blocks, but they will have different information inside them. I hope that makes more sense. Someone's saying, can we use a type def in this course? Oh, I'm not going to stop you from using it as you move on. Not yet, please. I don't want you to hide abstract meaning yet. Basically, structs are blocks that we've defined before the main code, and we can use whichever block we want for our code by telling struct name and variable name. Yeah, so you're saying that's right. You're declaring what you want to use, and you want to, and then what I'm using it as. And then to assign values to it, what I do is I use my variable name. Okay, so my variable name is my pizza. So I've got my variable name, and then because I can't just say my pizza is equal to, I don't know, X, okay, because where is this actually going to go? There's 3 components to this struct. So you've got to specify which member of the struct you're putting it into. So if I want to load it up into the name, what I do is I put a dot, and then I put in which one I want to put it into. So dot name, that was the part of there that I want to put it into. So my pizza dot name is X, and then I might have the size in the same pizza. So I might have again my pizza. Now I want to access the size one. So I'm going to say the size of that is equal to 5. And then I might have the price. I might have a my pizza, and I'm going to go in there dot price, and it's going to be, I don't know, 567. Super creative numbers. Okay, so what that means is that inside here, when I do this declaration here, I've just declared that I might possibly use something called a structure. But then when I get to line 22 in my program, what I've done is I've created this struct. I've created this struct, and this struct is called pizza. So I've created a pizza here, and this variable name is called my pizza. And inside it is 3 things. Inside it is a name, inside it is a size, and inside it is a price. Okay, and this one is a char, this one is an int, and this one is a double. And then when we go to line 23, you're creating another struct, and this one is called my pizza 2. And this one also has the same 3 components in it. It has the name, it has the size, and it has the price. And so when I go to here, line 26, when I say my pizza dot name, what that means is I want to go inside here, and inside here I'm going to place an X. Then when I go to line 27, I say my pizza dot size. That means inside here I'm placing an equals to 5. And then in here, I'm going to place an equals to 5.67. Why do we need to define the struct outside of the main? That is a very good question, and that's because you might have a few functions. So right now we only have one main function going, and that's it. But we might have a few functions going in our code. And what that does, declaring it outside the main, is that everyone has access to that structure. Yeah, name is a char because we haven't done strings yet, so we can't be superbly creative, just a little bit creative. So that's really, and then I can just print it out, right? So I can, and then I'll do enums after that. Okay, so let's print it out so you can see it in action. I don't know. The pizza %C is size %D and costs %LF. And then you just fill out all those placeholders. So my pizza dot name, my pizza dot size, and my pizza dot price. Okay, so then if you run it, then it's going to say the pizza X is size 5 and costs 5.67. Yep. Yeah, I mean, you can define a struct inside the main, but it's going to be a very useless struct to you because as we move on, we're really going to break things down into many functions, and so you're not going to have a lot of access to it. Why is this useful over defining variables? That is a very good question. Let's say I have, and this is a good example of students, I'm sorry, it is a good one. Oh, Tom's was writing that as well. Let's say in my class there are 765 students and each one of them has 7 things attached to their name, or even all the lab marks, okay? 10 lab marks attached to each student. 760 students with 10 lab marks each, that means I need 7,600 variables, okay? Whereas a structure will define for me what belongs to each student, and then it's related to each student. So I don't have to have student 1, lab 1, student 1, lab 2, student 1, lab 3, and so on and so forth, right? So it's a lot neater, it's a lot more easier to read, easier to understand code. So it's all about writing better code. Yes, I can do 7,600 variables, but does that make it, you know, good style? Does that make it good code? Does it make it efficient code? And so building on that, I'm going to show you another thing that is similarly, I really hate the way it just doesn't erase things for me. Yeah, you know, writing 1,000 lines of code for something that you can write in 5 lines of code, that's, you know, that's not efficiency. So you really want to avoid that. And as you know, in 1511, we don't care about efficiency. We just want you to be able to solve the problem to start with. But as you go on in the computing courses, if you do more computing courses, the conversation about efficiency is going to really take a lot more hold, because then we start caring about how we're using our memory resources, because then if we don't care, then our computers are slowed down, and if we don't care, the computer, you know, will not be happy, and neither will the person running the program, because they'll have to wait a long time. Okay, great. So now let's look at an enum, which is another data type that we can define. Okay, and it's another one that you can live without, but why would you live without it when you can live with it? It's just another thing that you can use, okay? One more item in your, you know, in your briefcase of things that you can use to write nicer, smoother code. So basically, so far we've learned about hash defines. We've learned about how to make a constant and assign something to it. Great, fantastic. All that enums are, they're enumerations, and they're basically integer constants. And what it means is that you can assign names to it, and that again makes the program easier to read and maintain. So a lot of these things have come about because things are easier to read and maintain. So when you have integer data types with limited range of values, that's when we use enums. And what that means is, for example, weekdays. I know that I've got 7 things, Monday to Sunday. Great, I'm going to put them down. And what will happen is that the enum, when you compile it, it enumerates them. It gives them each a number. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, okay? You can have a flag and you can assign values to it as well. So you can say, you can force assign values because otherwise we start at 0. And you can say what the values that you want to take. Okay, lots of good questions in there. What's the difference between this and arrays? Again, these are kind of like constants. They're not, an array is something that we can play with, we can manipulate. Once I compile this, I can't add anything to that enum. I can't change anything inside that enum. It's really just there to help me manage a large amount of things. And one of the greatest, I'll just give, there you go, see, I've gone back to ice cream. But, okay, imagine what happens, and here, I'll just go to this page then first because it's a good question. So what is the advantage of using these enums over the hash defines? Because really they're constants, right? But they are enumerated constants. Think about it this way. In the computer, and in your case, when you have these contexts where you have 5 or 6 things in an enumeration, you're like, well, why would I use it? And I don't disagree with you. 5 or 6 things, it's easy to do a hash define, okay? It doesn't matter. Imagine the computer error codes, okay? And I think this is a nice example because you might have 200 error codes. I don't want to be assigning numbers to each one of those. I can just say what the error code is, and then when I print out that error code, the number will come up, it will assign the numbers to it automatically. So this is why we kind of would want this enum going on. So you can have, they're automatically assigned numbers or values, and that makes the code much easier to read because you're not saying, this is equal to this is equal to this. And we really just use them when we want a variable to have a specific set of values. And so like in that lab question, the zodiac animals, you can do it without, but the zodiac animals don't ever change, so we might as well assign values to them as well. Yeah, I might use this to number students in a course. Potentially, yeah, assign them like their student IDs even. That's quite a nice example actually. And they follow scope rules as well. That means you can't have a state of an enum that's the same in 2 different types. What that means is if I have this weekdays here and this state flag here, I can't have a Monday inside here as well if it's in the same piece of code. So there's scope rules that you can have the same values given to them by forcing it, but you can't have, 2 of the same states in the same thing. So let's do let's do just a simple demonstration so I can show you what it's doing. I'll do this piece of code, in fact. Where's my, here. Okay, let's do an enum. Okay, enum, same as a struct. I'm going to define it outside. And I'm going to call it, I don't know, weekdays. It is there to improve readability, absolutely. And it just improves your code. Inside curly brackets, I'm going to list out my weekdays. So notice how here we do commas after each item that you're listing. And that's what we're going to do. Oh. Great. Okay. And then inside here, again, the same as with the structs, I'm going to say that I'm going to use which type of enum and I'm going to give it a name. Okay. So exactly the same as we do with a struct. So let's say I'm going to say I want to use this enum in here and the enum is called weekdays. But I'm going to call my variable name day. And remember, because you might have a few things here happening after, you might have more than one enum. And then if I print out And remember, it starts counting at 0. So I'm calling for that variable day. And let's see what it returns to us. Let's see what it outputs to the terminal, not returns. Oh, didn't mean to do that. Okay, let's compile. Ah. Okay, there we go. We've got the error, and it's because the struct and the enum, think of them exactly similar thing. Add the comma because you can also have something in between there. Okay, let's try that again. Oh, I forgot to assign a day to it. Huh. Okay. So I forgot to I said I'm going to have this variable, so I've declared it here. I've declared an enum, but I forgot to actually assign any value to it, which is a bit of a problem. It has no value inside it right now. So I need to give it a state. Let's say I'm going to give it the Thursday as the state. Okay, let's try that now. So compile and run it. And it's going to output the day is 3 because 0, 1, 2, 3. So it outputs like a 3. So basically, you use enums to improve the readability of your code, because it automatically assigns values to these things. So then you can have a bunch of related constants that are, grouped together, because they have to be related. They can't just be random things. It's basically a custom data type. So you're creating this data type. You can also have states, so you can have, success, failure, whatever. You can have those types of different things. Okay. Tom, could you please just quickly poll that? Yeah, and so as Tom is saying as well, they're ordered numbers. So if I force this one here, this Tuesday to be 4, okay, what do you reckon? And you can force numbers. What do you reckon the Thursday is going to be now? Let's take guesses. Take guesses. What's going to be the Thursday now? Ah, clever poppets. Very clever. Okay, so the thing with enums is it goes, if this is still 0, this is now 4. What it does is it adds 1 onto the previous one. Okay, so it's going to go 0, 4, 5, 6, 7, 8, 9. So it always just adds 1 more. Tom's freaking out over here. I don't know why. Oh. Let me have a look. The poll. How are you feeling about enums? Okay. Not bad. Don't worry if it hasn't clicked yet. Again, we're going to use them throughout, and you're going to get a bit more of a feel for them as well. Yeah, it's going to be hard to kind of get everything going. I can do a while loop and just keep on printing. So what I can do is why not? Let's go crazy. I can assign the day as the first one. And then I can say whilst, I really want to use a for loop. No, I'm not going to do it. Yeah, so enums only return numbers because they're enumerations. They don't return what it stands for. But that's what makes the code much easier to read, right? Because you've got actual values, not the numbers, and you don't care as much about the values. And when you see, the error codes, when you get like blah, 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 they give a description and they're like error code blah. Often that's an enum as well. Yeah, Tom freaked out when he saw the poll because he wasn't sure that he's doing the right poll. He's doing the right poll. Yeah, he's okay. He's okay. So we can do this. Let's say I want to start on Monday, and then I'm going to say, okay, whilst day is less than or equal to Sunday, I'm going to print out the day. And then I'm going to add 1 to the day. So I'm going to do that, and then I'm going to update it. I'm going to day plus plus it. And then if we run that, let's compile it. And let's run it. And so now it's basically going the day 0, the day's 1, the day's 2, 3, 4, 5, 6. So you can kind of do it through. Yeah, so you can use the enums to define zodiac signs. That's right. So it makes it more readable. I worked so hard to come up with that context of the zodiac animals. It's all right. It's really hard to demonstrate why you need to use an enum without having a large data set. You can do all of these things with just hash defines. These things really come into play a lot more when you have large chunks of data that you need to deal with. That's the problem. So inside the enum, okay, I can have anything I want in here, okay? But each one of these items is going to have an enumerated value assigned to it, an integer, when it compiles. It always starts counting at 0 unless I give it my own values. So I can have whatever I want. It's not about the data types in there. So think of it as like a hash define, right? But it's a hash define of many things that are related together. So if I were to do that enum without, it would be define, I don't know, Monday as 0. Then it would be define Tuesday as 1. And so on and so forth, okay? All the way down. Whereas the enum lets me group them together and it lets me have them as 1, and the compiler will do it automatically, give them numbers. All right, one thing I wanted to do just very quickly is to show you how to move something outside of your main function, okay? So int main, we've talked about it. That's where things start happening. Let's say I want to have it, and this is for that print dir exercise. Let's say I've got a procedure, right? So let's say in here I've got a printf, hey, great, I love 1511. I'm gonna finally do it. I love 1511. Biased opinion. And then I'm going to return 0. Let's say I want to move this printf statement out because it's a procedure. It really doesn't return anything. So what I would do is I would declare a procedure here. Okay, so first of all, I'm going to include my stdio. But then if you remember, the int here is what tells me that something is being returned, and that's when I'm returning 0. So a procedure doesn't use the keyword return. So it's going to be a void because it's not returning anything. And I'm going to call it a print function because I'm not really giving it anything. So I'm going to have a void here as well. And then all I'm going to do in here is I'm going to have my printf statement. Now notice, because this is void over here, I don't need to return anything here. But now I need to ask main to call that print function for me. Okay, and what I'm going to do is I'm just going to say print, and what its print is going to do is it's going to call the function. Okay, it's going to call this function over here. So if I save this now, and let's try and run it. Okay, great. So what's happened here? On line, and this is a common mistake, sorry, this is why I'm doing it. On line 13 of procedure.c, you're performing an operation but not saving the result. Did you mean to print or store the result in a variable? It's got no idea what I'm doing because I'm not really telling it to call something. So because it is a function, even if I'm not giving it anything, I'm going to pop the brackets in because I'm calling it. So let's try running it again. And now let's try running it. And it's printing out, hey, I love, by using this procedure and the function. So we're breaking it up into functions, really. In C, mostly everything's considered to be a function. But when it doesn't return anything, procedure. And you will see the use for this later on, okay? Right now, you're just kind of getting, okay, this is a linguistic rule, doesn't make much sense why we have it. It will make sense later because it's a much safer way to code to have these things because one cannot return you rubbish, the other one can, and so on and so forth, okay? So lots of the things that we do really impact how humans read it and what mistakes humans make when they code. Okay, questions. Questions? No questions. Tom's been answering questions. Tom looks exhausted. Not fast enough. Type faster. Everyone okay? I'm just reading through the chat. Yeah, so if you've done the zodiac animals in a different way, try and do it with enums so that you kind of get to see, you kind of get a feel for using enums as well. It did escalate a little bit. I'm sorry, because I was trying to cover off the lab. Really, are we still going to code the pyramid? We're going to do the pyramid next week. Otherwise, we're just going to run out of time and it's going to be too stressful. How will we take... Yeah, I think Tom is answering it. Tom is answering the zodiac questions. Yeah, you're going to have two loops for the pyramid as well, but there's, it's just where you reset it for it to print in a pyramid shape as opposed to just a beautiful, grid, triangle, not triangle, square. Yeah, so procedure's just something that doesn't return anything. It's a void, it's just a print. But I'm just showing you this so that in your lab you know how to move something outside of the main. And note, I put it before the main. Because otherwise, if it's below the main, it's not going to know that it exists. Remember, because C reads line by line by line by line by line. And don't worry, we're going to go through lots of these things as a refresh next week as well. And next week, we're going to start looking at functions, which is super exciting. So we're going to look at how we can break up this code even more when we write these big chunks of code. Again, for human readability. Okay. Let's do feedback. If you have any feedback from today, if you want me to go over anything in specifically from today's lecture on Monday, please just pop it in the feedback as well so that I know what to go through, like what specifically you would like me to go through. And I will do a Kahoot just to see where we're at. I've already know some things I'm going to ask from today's Kahoot again. Yeah. You can see the enum code. I've uploaded it, haven't I? Have I? Let me move this out. enum code. Yeah, saved. It's not saved. Oh, there's nothing. It's because I did those defines. And you will discuss more things in the lab. Please use the labs to ask lots of questions as well. Okay, I'll go through enums again. Don't worry. And look, enums is not a huge thing, right? Your life will not really be hugely affected if you. An enum is just a way to define many constants together and have, you know, to not have your brain power used to enumerate them. Okay, so it's not a huge thing. It's not something that I would worry about if you don't 100% understand it yet. In fact, you probably will not 100% understand it until you start using it. And chances are right now we're forcing you to use it just so you get a feel for it, but you don't really get a feel for it until you get big sets of data together. All right, everyone, thank you so much for joining on a Wednesday. I hope you all go and have some lunch now and enjoy the rest of the day. It is meant to start raining, unfortunately, so enjoy what's left of non-rain. But yeah, have a great rest of the week, and I will look forward to seeing you on Monday. Please let me know any questions as well. Just post them on the forum. I'm surfing the forums, so yeah, we're answering them quickly, I hope. But yeah, have a good rest of the week. Thanks for joining us. We'll see you on Monday.